discussing about dictionary and ranking system in dictionary earlier class. So today we have a previous year question from the toughest NDA paper of 2016. So we have to find the number of words with or without meaning that can be made using all letters of word again. If these words are written as in the dictionary, means in an alphabetical order, then what will be the 50th word? That is the question. Okay, so let's first understand that what is given to us. Again, word is given to us. Let's rearrange the word as per alphabetical. So A, then comes G, then comes I, then comes N. So five letters, one letter is getting repeated, that is two. So how many total arrangements can be made? 5 factorial. And whenever there is anything getting repeated, if it is getting repeated twice, then we divide it by 2 factorial. If it is getting repeated thrice or 4 times, then we divide the factorial of the same number that it is getting repeated. So basically, total number of permutations among the word again having 5 letters with A being repeated twice will be 5 factorial divided by 2 factorial. Is this clear, everyone? Yes? 5 factorial is 120 divided by 2. That becomes 60. Okay. Now we have to discuss about all the words that can be found using these letters, these 5 letters. Okay, so the first letter, and we have to find out the 50th word. So let's find out. First, let's try to write them. See how many words we'll be able to make with A as the initial letter. So after A being the initial letter, how many other letters are remaining? 4 letters are remaining, 4 places. So 4 factorial. Okay, cool. So 4 factorial is what? 24 numbers. But we need to find out, we need to go to the 50th word. Okay. Let's go to the next letter then. After A, then comes G. Okay. Then how many letters are left? 4 places are left and 4 letters are left. Now this time, what letters are there to be filled? 4 choices do we have? And 4 letters. A, G is already used, IN. Out of these 4 letters, there is something unique here. That A is getting repeated twice. So you'll have to divide 4 factorial by 2 factorial. Find out the total number of arrangements. So 24 by 2 becomes 12. Okay, 24 and 12 makes up to 36. But we have to go to the 50th word. So let's continue. After G comes I. Again, 4 places with 4 letters, but with A being repeated twice. Again 12. So 24 plus 24, we are now on the, we have skipped 48 words till now. Okay. So let's have some more space. After I comes N. Okay. Now we have to not skip all the words because we know we have to discuss of 50th word. So whatever the next word will be the 49th word. So 49th word will be, after N comes naturally A, then again A, then comes the G, then comes I. N is already used. So this is the 49th word. So the 50th word, after N, A comes IG. Getting it? Now, here, in the last word, there will be a word used after that comes, that like makes it something other. So that comes Basically after I. Is there any word which comes after I that is left? No. Every other word is used, so we cannot change here. Let's look for the next position. After G comes I and N. N is already used. I we can use here. So we'll use I here and G here. And this is the 50th word. Is that clear, everyone? This is the answer. Any doubts?
No, sir.
Okay, then let's move ahead. Next concept is of circular permutation. Till now, we were discussing about permutations in a linear order, like we were arranging people on benches, in lines, in spaces which are arranged in straight lines. Straight lines basically it means just not straight line, but basically it have a starting point and it has an end point. We were arranging people on that. But now what has changed? There was a starting point, so there was an end point. Now in a circle, there is no starting point and there is no finishing point, the end point. There's no end point, no starting point. So this time things will be a little different. Let's say there are some chairs, okay, arranged in circular manner. Let's assume this is a circle. Okay. If we have to make some people sit on this particular on this particular chairs, then they are going to sit in a kind of a circle, right? Now, what is different this time? Earlier, we could have started from any point. Like if there are 7 chairs here, there are 7 chairs in a linear format. So this is the starting chair, this is the final chair. That is the specialty here. Not to define our arrangement, who's the first, who's second, who's third. But is no such reference point. Here there were two reference point, the starting point and the end point. Here there is no reference point. No reference point. So we need to create one. Okay. We will create a reference point by ourselves that this is the chair of the president. Okay. Now there is a reference point that to the chairman, to its left. This is the first position to its left, to the left of the chairman. This is the second position to the left of the chairman. This is the third position to the left of the chairman, considering his face is towards the center, right? This is the first person to his right, second person to his right, third person to his right. That's how we will be able to refer to positions when we will consider a reference point. We need to consider a reference point. So now, as considering how many ways that we can arrange certain people, or let's say 7%. So let's say if it were a linear case, so 7 choices for this place, 6 choices, then 5 choices, 4 choices, 3, 2, and 1. So basically 7 factorial. But this time we have already chosen a reference point. So only chairman is going to sit at here. Basically, the person who is designated, who is chosen as the reference point. So only one choice for the reference. Now, how many remaining? 7 minus 1, 6%. 5% can sit. 4 choices are there. 3 choices are there. 2 choices, 1 choice. If we multiply them all, this becomes 6 factorial. So we can conclude that to make certain people sit on in a circular permutation, we have to arrange n number of people on n places around a circle. Then the formula, the total number of permutation will be n minus 1 factorial. Is that clear, everyone? -1 because we have to choose a reference point. So if we are choosing someone as a reference, so there is no other choice other than the reference person or the reference thing that is there. So total number of this is the number of ways of arranging n persons at a round in a round manner. And elements in a round manner. Okay, is that clear, everyone?
Yes, sir.
Great. So please keep a note of this. Okay, so we have already discussed about circle. What about semicircle? Permutations in semicircle I should have written. Anyways, so about semicircle, it is basically the same, like, but there is certainties which are different. So here are two choices available at the starting. Let's take an example of a necklace. Okay. So you have two choices for it, like arranging the beads of the necklace. Okay, am I taking the right name? Are the beads? They're called beads, right? Bead of necklace. Yes, yes, yes. So beads can be arranged in two manners. One is that we may insert it from the in the in this manner, in this direction, which is anti-clockwise. Or we may go in a clockwise direction from starting from this end. Okay, sorry. Starting from this end or starting from it's the same, I guess. Or starting from this end. Okay, there are two ways to go about it. So that is why the total number of permutations that can be made using n elements in a semicircle is simply n minus 1 factorial divided by 2 because we have choice to go clockwise or counterclockwise. Is that clear, everyone?
Yes, sir.
Yes. Two choices available. Whenever there is any repetition in any word, we used to divide it by the factorial, right? So that's the same logic here. So let's jump on this question. The question says, how many ways, in how many ways can 6 persons be seated? First part, in a line. Okay, for a line we knew basically n factorial That should be 720 factorial. 720. Okay. In a on a table. Okay. On a table. So n minus 1, n is 6, 5 factorial. That is 120. That's the basic application. Clear, everyone? Coming to the next question. In how many ways can five, this is a previous year question, five ladies and five gentlemen can be seated at a round table so that no two ladies are seated together to chit chat, to gossip. Okay. So, can anyone tell me the answer? How to solve this particular problem of avoiding the chit chat all over the dinner? So, it's simple that there are 10 people, so there will be 10 seats. You have to add one more. Okay, there are 10 seats. First, we need to fix someone. Okay, so let's say we have fixed a male person. Then, okay, now we have nine seats left. Then, if there is a male, then there should be a female here. There should be a male here, female here, male here, female here, male here, female here, male here, and then female here. Cool. We have chosen this person as our fixed seat, as our reference. So out of how many seats are left now to be filled? Nine seats are to be filled. Out of which five are to be filled by women and four are to be filled by men. Five seats, five women. How many arrangement? Five factorial. Four men, four seats, four factorial. They are dependent tasks because they will affect the sitting on the table. So 5 into 4 factorial should be the answer, which is 120 into 24. That should be 12, 12, 144, 288, 0. This should be the answer. 2,818 manners are there just for 10 persons to sit in a specific manner. Clear? Is there any doubt?
No, sir.
In how many ways can five ladies, five gentlemen be seated at a round table so that no two ladies are seated together? We have to fix a seat. We can fix that with male or female. It's just your choice. Thereafter, you have to arrange nine persons, out of which five women and four women are needed to be arranged. Five women on five seats, 5 factorial, four women on four seats, 4 factorial. They both are independent, dependent tasks. So that is why the multiple will be taken in both of the number of cases. It will make it a answer. It will make our answer as 2,880. That's a previous year question. Clear?
Yes, sir.
Great. Can five beats of different color from a necklace. Sorry, my bad. Form a necklace. Okay. So we have to find the total number of ways. Okay. So there's a necklace. So that will be in a semicircle. 5 beads are there. Okay. If it's going to be get arranged in it. Basically, why we are considering n minus 1 factorial? Because after arranging, we are going to tie a knot. Okay. And that's how it's going to become a necklace. Before that, it was in this shape. Okay. 5 minus 1 factorial divided by 2 because we had choice. 4 factorial 25, 24 by 2, that is 12 total number of cases. That is their answer. Is that clear, everyone?
Yes, sir.
Okay. We have learned how to make necklace. Maybe that can help to boys. Combination. Shall we move ahead to the next topic? Any doubts? Any doubts?
No, sir.
Now, permutations, we were discussing about the arrangement. Like first selecting R element from N and then arranging those R elements in among themselves. Now this time we are just going to select R elements from N and doesn't matter, the arrangement doesn't matter for them. Like let's say, let's write a set A, E, I, O, U. Now this set is equal to E, I, O, A, U. This set. They both are equal sets because they have equal elements and arrangement doesn't matter. So also it's the same story with the combination. We just will make selections. So combination is basically selection of R elements, objects, bodies, things out of N, basically. Now, how do we write it? NCR, its formula is N factorial, N minus R factorial. And this time, the permutation was this, N factorial upon N minus of R factorial, where we were arranging our things. So if we arrange our thing, that is R factorial. So we are going to divide the permutation formula by R factorial to make it a combination of the formula because we are just looking at the selection process. Okay, we are only looking at the selection process. So this is the formula. NCR is equals to N factorial upon N minus R factorial by R factorial into R factorial. And we can also write it in this format. NCR is also equal to NPR divided by R factorial. It can also be written like that NPR is equals to NCR into R factorial. So from here you will be able to understand it very nicely that the permutation of R elements out of N is the first selection of R elements out of N and then the arrangement of R element among themselves. Clear, everyone? Any doubts? Any thoughts? I want everyone to read this slide once again. It's very important. Got it? No?
Yes, sir.
Okay. So let's now solve the question. it is given that NC8 is equals to NC of 6. And we have to find out what is NC of 2. Okay, let's apply the formula. On the left hand side, n factorial upon n minus of 8 factorial into 8 factorial equals to n factorial divided by n minus 6 factorial divided into 6 factorial. N factorial cancels n factorial. Okay, let's now cross multiply and expand n minus 6 factorial because it will go ahead and will make itself n minus of 8 factorial into 6 factorial was there. Goes on to the right hand side. Now n minus 8 factorial, this particular term and this particular term cancels each other. Okay, cool. Now n minus of 6 into n minus of 7 becomes 8 factorial divided by 6 factorial. 8 factorial can be expanded as 8 into 7 into 6 factorial. 8 into 7 into 6 factorial. 6 factorial, 6 factorial cancels each other. Now we can look clearly here that n minus 6 into n minus of 7 equals to 8 into 7. Now we can clearly observe that n minus 6 is going to be greater. So let's assume n minus 6 to be 8, n minus 7 to be 7. n comes out as 14 from here, and it is the same case from the second statement. So our assumption is correct. N is 14. We needed to find out NC2. N is 14, C2, applying the formula 14 factorial upon 14 minus 2 factorial, that is 12 by into 12, 2 factorial. 12 factorial cancels 14 by 14 into 13 into 12 factorial, that gets cancelled. 2 factorial is basically 2, so 7 into 13, that is basically 91 is your answer. Is that clear, everyone?
Yes,
No
sir.
doubts? Any doubts? Any doubts? Okay, let me make the solution more organized. So instead of doing all this, if we just observe the formula of NCR and make some conclusions out of it, we might get helped. Okay, how particularly? Let's discuss. Find out first. Let's observe 5C1 is 5 factorial divided by 5 minus 1, 4 factorial into 1 factorial. How about 5C4? 5 factorial divided by 5 minus 4, that is 1 factorial into 4 factorial. Are they both the same? Yes, they are the same. What if I write NC of R, that is n factorial upon n minus of R factorial into R factorial? What if I write NC of n minus of R, then n factorial divided by n minus of n plus of R into factorial into n minus of R factorial? If we solve it, it becomes n factorial divided by R factorial into n minus of R factorial. Are they both the same? Please observe carefully that are they both the same? This is something very important. Are they the same? Are their results the same? Yes or no? Anyone? See, please don't be afraid of giving wrong answers, but be afraid of being silent and knowing and learning the wrong thing. Okay? So please don't be afraid of failure. The sooner you fail, the better you will be for the rest of your life. Yes, now please tell me. It's a very little thing. NCR is this equal to this or not. Don't think much, just whatever your first thought is, just give that. That is correct. Great. That's not, I'll correct you. Anyone? I guess everyone slept then. Yes, they are the same. So hence we can conclude that NC of R is equal to NC of N minus R. That's a really important theorem, going to be useful. And similarly, we can say that NC of R plus NC of R minus 1 is equals to N plus 1 C of R. Okay, so you might want to know how this is happening. Okay, let's then discuss the same. Solving as per the formula. N minus of R plus 1 factorial into R minus 1 factorial. Okay. Now this will expand as N minus of R plus 1 into N minus of R factorial. This will expand as R into R minus 1 factorial. Okay. So instead of these, let's write their expanded form to do better, convenient for us. Right. Instead of this, let's write its expanded form. Okay. Now we can see that this particular n factorial in the numerator and n minus r factorial and r minus 1 factorial is common in between both of them. This is the right hand side. So taking common n factorial divided by n minus of r factorial into r minus of 1 factorial. Now what is left inside? 1 upon r plus what is left here? 1 upon n minus of r plus 1. Okay, else whole is taken common. Okay, let's now increase the space. Okay, that's better. So now let's take LCM, which is okay, let's take LCM R into n minus r plus 1, and this will become n minus r plus 1 plus of r cancels each other. So the denominator into whatever that was there, r minus 1 factorial. Okay, so I'm solving the left hand side further. So n factorial into n plus 1 divided by n minus of r factorial into n minus of r plus 1 into r minus 1 factorial. So from here, using the formula that n factorial is equals to n into n minus of 1 factorial, we can say that this is equals to n plus 1 factorial. Okay, cool. This becomes equals to n minus r plus 1 factorial. Okay, cool. Now this becomes r factorial. Okay, cool. So we can write it as n plus 1 factorial divided by n minus of r plus 1 factorial into r factorial. Great. If we so we may write this as a formula of n plus 1 c of r, which is the right hand side, and hence our 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 property is proved. Is there any doubt, anyone?
Sir.
Okay, great. So let's move ahead then. Okay, so using the same property, we could have solved this particular question. Let's find out how. We know NC of R is equals to NC of R, NC of NC, NC of N minus R. So if this is 8, so one thing from here we can conclude that R plus N minus of R should be equaling to N. So if the sum of both here is equaling to the N here, then they're definitely equal. So if they are equal, so 8 plus 6 should be equaling to N. So N is 14 here. Now from this, directly our question is solved. Okay. So let's modify our property that we have written here. From where we can conclude that if NC of X is equals to NC of Y, then X plus Y should be equals to N. That is the property. Great. So using the property, we have been able to solve the question. There's one more manifestation of the second property that I have written. Let's discuss the same. Let's raise R plus 1. It's mostly the property is same. Then basically N plus 1 and C R plus 1. Basically, whichever R is greater, you have to use that R. Here R was greater. And you have to raise the N should be equal. And after N being equal to N, you will have to raise its value by 1. Okay, that's the game basically. Okay. Okay, let's now discuss some more theorem of combinations itself. Let's discuss about the division of NCR by N of C of R minus 1. So I have a trick to remember it. N minus of R minus 1, that becomes N minus of R plus 1, and simply the R. Okay. Using the same, you can also interpret for this. So basically N minus of R and basically the R the same. Clear. These are two properties derived from previous year questions, have been repeated multiple times. Please take a note. Clear? Shall we move ahead? Any doubts, any questions?
Yes, sir.
Okay, let's solve the question now. If it is given that 18 CR is equals to 18 of CR plus 2, then we have to find RC of 5. Now, always remember that factorials, negative numbers factorials do not exist. So NCR, whenever we're writing, N has to be greater than R. That's a simple logic, because if N were be less than R, then N minus R factorial will be imaginary, not existing. Okay, let's now discuss this question. So if there are like NC x is equals to NC of y, then x plus y should have to be equals to n. Here r plus 2 should be equals to 18. 2r plus 2 is equals to 18. 2r becomes equals to 16. R becomes equals to 8. Right? So if r is 8, 8c5 is 8 factorial upon 8 minus 5 factorial into 5 factorial. 8, okay, 5 factorial cancels 8 by, so 8 can be expanded by 876 into 5 factorial, which is get cancelled. So 3 factorial is basically 6, 8 into 7 is 56. Any doubts, anyone? That's how discussion is being solved. Is there any doubt, anyone? If there is any, please ask. Okay, so let's not waste our time then. Solve questions. 2nc3 is 2nc3. Ratio is given as 12 is to 1. Now we have to find the only variable that is there, n. Okay, if it is so let it be like that and let's write the formula. 2n is 2n fact back. 2n factorial upon 2n minus 3 factorial into 3 factorial is equals to n factorial upon n minus 3 factorial into 3 factorial. Oh, sorry. That is there in the denominator. Okay. So if it is like so n factorial will be getting multiplied with the denominator. Let's write it here. And this will be getting multiplied to the numerator. Okay. And the ratio is given equals to 12 is to 1. Is there any doubt, anyone, that how have I done so? How have I written it like that? Why exactly? Any doubts?
No, sir.
Okay. Then 2n factorial will be expanding like 2n into 2n minus 1 into 2n minus 2 into 2n minus of 3, and let's stop it here. Why? Because 2n minus 3 factorial is there. We'll cancel 2n minus 3 with 2n minus 3. Cool. N factorial can be expanded as n into n minus 1, n minus 2 to n minus 3 factorial. Let's stop it because n minus 3 factorial is there. So we have been able to solve for every factorial. 3 factorials cancels 3 factorial. Great. So it will become 2n into 2n minus 1 into 2n minus 2 into nothing divided by n into n minus 1 to n minus of 2 equaling to 12. So it's always better to eliminate options whichever if they are given to us, right? But in this case we are being unlucky. Let's solve. Now 2n will get multiplied, will get divided by n for sure because there's nothing like n minus 1 and 2n minus 1 are completely different terms. But n and n can get divided here, and 2 can also divide 12 by 6. Great. Now things are doable for us. Okay. So this can be written further written as 2n minus 1 into 2n minus 2. Let's expand the quadratic equation. Okay. So this will become 2n minus 2n into 2n 4n square, 2n minus 2 minus of 4n minus of minus 1 into 2n minus of 2n minus 1 into minus 2 is plus 2 divided by n minus 1 into n minus 2, so n square minus 3n plus 2 is equals to 6. Now we shall divide these two polynomials. So the division of polynomial will be like this. Let's write to the numerator inside. And the denominator here we write. What the hell is this doing here? Okay, so first things first, we have to make the highest degree. We have to make the highest degree of this any particular. Basically, we have to look here the highest degree. We have to write the polynomial in a decreasing power, in a decreasing degree power. So we have to first make it completely subtracted to 0. So how we can bring 4n square here? By multiplying 4 with the divisor here. Okay, 4n square minus of 3 minus 12n plus of 8. Now we'll subtract, so we'll change the sign. This becomes 0 as per our objective. 12n minus 4n becomes 8n minus of 2n. Okay, so we have done mistakes. Let's simplify it first. Minus 4n minus 2n will become minus of 6n, and plus 2 of course is there. So now 4n square plus 12n minus 6n will make it plus 6n, plus 2 minus of 8 minus of 6. Can we further divide it? No, because its degree is less than the divisor. Okay, so we'll leave it like this only. Okay, so we are not able to completely divide them. Okay, let's try some other method then. Go back. I've been able to observe now something. 2n minus 2. 2 can be taken common, n minus 1, n minus 1 cancels n minus 1. Great, yeah. Now the equation has become linear. So 2 into 2, now 2 cancels 6 by 3. Okay. 2n minus 1 is equals to 3 into n minus 2 that is left. 2n minus 1 is equals to 3n minus of 6. Minus 6 plus 1, sorry, minus 6 will make itself positive when it comes to the left hand side, equals to 3n minus 2n. So n becomes 5. Cool. We have the answer. N is equals to 5. And if we had options here, then from here itself we could have substituted for the value of n. Okay. Is there any doubt, anyone?
No, sir.
Yes. So we did a mistake. We didn't observe the term correctly. I did a mistake. TP. Next previous year question is, if it is given that NC of R minus 1 is equals to 36, NC of R is equals to 84, and NC of R plus 1 is equals to 126, then we have to find RC2. Nice question. So here we know the formula of NC of R divided by NC of R minus 1. That is basically N minus R plus 1 upon N minus of R. And we also know the value of NCR and NCR minus 1. And we also know the formula of NCR plus 1 upon NCR. That is N minus of R upon R plus 1. Cool. So let's find out. NCR is 84 divided by NCR minus 1, that is 36, equals to N minus R plus 1 upon N minus R. Okay. NCR plus 1 is 126 divided by NCR, that is 84, and that should be N minus R plus 1. Okay. So let's now we have two variables and two equations for that. We'll be able to easily solve. So 12 7 ja 84, 12 3 ja 36. Cross multiplying 7n minus 7r is equals to 3n minus 3r plus of 3. Let's bring all the variables on one side, left hand side. 7n minus 3n makes it 4n, minus 7r plus 3r will make it minus 4r is equals to 3. So we may conclude from here that n minus of r is equals to, or 4 of n minus 3 of r is 3. From here, this can be get multiplied by 6, okay, and but this will not be, yes, this will also be get multiplied with 6. 2 is 12, 6 1 is 6, 6 1 is 6, 6 4 is 84. We can get multiplied, we can divide them both by 7. 7 2 is 14, 7 3 is 20. Let's cross multiply 3r plus 3, 2n minus 2r. Let's get all the variables on the right hand side. 3 is equals to 2n minus of 5r. We now have two linear equations. So let's substitute n. What we want? R we want. So let's substitute n in the second equation. So n was n minus of 3 is equals to 3 by 4. N is basically 3 by 4 plus r. What is the second equation? Second equation is 3 is equals to 2 of n minus of 5r, right? So instead of n, we have 3 by 4 plus r. That's all. 3 is equals to, when 2 into 3 by 4 will make it 3 by 2 plus 2r minus of 5r, which will make it as a minus of 3r. Let's bring the minus 3r to the left hand side and 3 by 2 minus of 3 right hand side. Are we doing any mistake? I suspect so. Let's divide it. Yes, we are up to a mistake because r cannot be negative. Let's recheck. So what was happening? 3 plus 4 to r. Let's check the equations. Then r is equals to 7 3. Okay, so we have done a mistake here in writing the formula. R should be there, like r plus 1 is there, na? So here should be r instead of n minus of r. Yes, that's the mistake. Apologies, everyone. N minus r should be there. Single mistake in whole. R should be there. What was here basically? 7 by 3 after 84 by 36 has become 7 by 3. 7r is equals to 3n minus 3r plus 3. Now this has become 10r is equals to 3n plus 3. We should substitute the value of n. R is 10r, 10r minus 3 by 3. So n is basically 10r minus 3 by 3. Not this. N is 10r minus 3 by 3. Okay, let's solve the equation then. 10r minus 3 by 3. Now let's multiply by 3 on both sides. This will become 9. 2 into 3 gets cancelled. So this has become 2 into 10 minus r, 20r minus 6, minus of 5 into 3, minus 15 of r. Okay, 9 minus 6 becomes 15. 20r minus 5r becomes 5. 20r minus 15r becomes 5. 5 gets divided and r becomes 3. We have to find RC2. 3C2 will be 3. 1 factorial, this will be 3 basically. One more thing to know, NC minus 1 will be N only. Will be N only. That's an observation. Simple. N, because N factorial divided by N minus N plus 1 into N minus of 1 factorial. So this is simply 1. And N minus N factorial divided by N minus 1 factorial is basically N. So NC N minus 1 is basically N. And it is the same with NC1 also. Okay. So first you tell me, is this question clear?
Yes, sir.
Yes, it's time also to conclude our class. Before that, what observation we have just made, I would like to write it again. Let's write it here. Shall we? Yes. So NC1 is and NC of N minus 1 is N only. Okay, thank you everyone. Any questions? Any questions?
No, sir.
Okay, thank you everyone. Jai Hind.
Thank you, Sir.